So we're back at Remember the Alamo, and what we're going to look at is just basically a little bit more of the ideas behind it, and then we're going to do a couple problems, and then you're going to practice it. Alright, so this number, the 6.02 times 10 to the 23rd, it is considered Avogadro's number because good old Avogadro, let's just get, there we go. Good old Avogadro is the one that came up with it. So that's me right now. Now it's being finicky. So anytime we say Avogadro's number, that's what we're talking about. Here, I need to switch something out on my pen, so I apologize. Okay, so what you want to keep in mind is that particles can be a lot of things. So remember, they can be atoms, and that's going to be an element alone. Ions have charges. You're going to see that my handwriting is really bad with this little slate thing. Molecules mean that it's covalent. And last but not least, formula units means it's ionic. So you want to take a second, just try and do the following examples. Figure out which one's an atom, an ion, a formula unit, and a molecule. So the first guy, good old gold, is an atom. So he's the first guy we talked about. Should have that. SO4 minus 2 is your ion. Molecules are covalent, which means that CO2 is a molecule. Sorry. And last but not least, NaOH would be our formula unit, so our Fu. And you need to be able to do this because when you're writing your answers, you have to have the right kind of units. If you don't have the right kind of units, you're not going to get the point for the unit. Okay, so something that's very important but kind of confusing for people is molar mass. You find molar mass the exact same way as you find atomic mass and formula mass. It is the exact same number, but it means something completely different. Formula mass and atomic mass mean things on a microscopic scale. Molar mass means a whole mole of something. So it means if I have 6.02 times 10 to the 23rd of something, how much does that weigh? So it's very tricky because it's so simple that it seems like it can't be right. But that's kind of what's the nice thing about Avogadro's number is it allows us to do that. So if we're going to find the molar mass of water, what you're going to notice is it looks exactly the same. So if we're going to do hydrogen, we do 2 times 1.0. Oxygen is 1 times 16.0. Now when you add it all up, you get 18.0. The difference, though, is this is no longer in atomic mass units. This is in grams per mole, and we're going to use that as a conversion factor in a little bit. Over here for nitric acid, H is 1 times 1. Nitrogen is 1 times 14. And oxygen is 3 times 16. So you put that in your calculator. And we get for nitric, it should be 63 grams per mole. The idea that they're different, though, is very important and something you need to understand for the test to do well. Because you do need to be able to see that there's a difference. Alright, so what we're going to focus on now is called the molar brick road, and this is having to do with mole conversions. And what you need to see is that moles is the center of this whole chapter. Everything is basically off of moles. So no matter what you're given, you can always go to moles. If you have moles, you can basically get anything. But you have to be aware of where you're starting and where you're going to do the problems. So the first type of problems we're going to do are moles and mass. So if we look back at this chart, what we're doing is we're dealing with masses and moles. So what it's showing us is to go between these two, we need our molar mass from the periodic table. We can use it any way we want, but we need to use our molar mass. So the first question is, we want to know how many grams are in 3 moles of water. It's definitely in moles to mass. We want mass, we're given moles. And remember, when you're doing these type of problems, you always write what they give you first. So we have 3 moles. Now, we need a conversion factor that takes us from moles to grams. And if you just think about what we just talked about, what we're talking about, and I'll come right back to this, is molar mass. So we need the molar mass of water, which we, by happenstance, just already found. So what we're going to use is that we know that there's exactly 18.0 grams in a mole. What that allows us to do is cancel things. So our moles cancel. We're going to get grams, and that's our answer. So we're going to get 54.0 grams of water. And just so you're aware, you need all of this for your answer. So you need the number, you need sig figs, you need the unit, and you need the chemical. If you don't have that, you're not finished. Down here, number 2, it's also a mole to mass problem, because now we want moles, and we are given grams. This time we're looking at gold. So again, you always start with what they give you, 45 grams. We're going to make a little thing here. Now, I need something where moles is on top and grams is on the bottom. It's still the molar mass. All the only thing that's different is we're putting on the bottom, so we divide by it. But it's the same exact thing. So what we need to do is look up on the periodic table, what does gold weigh? And if you look that up, it's 197 grams in a mole. So to do the math, I'm going to take 45 times 1 divided by 197. And you should get, hold on, let me just see if I actually get exactly that or if I need to write it out. Okay, so you get this big thing, 0.228426, that's 639. You need to round it, and what's important is what you started with. We had 3 sig figs, that means our answer has to have 3, so our answer is 0.228 moles of gold. So we have the number right, we have our sig figs, we have our unit, and we also have our chemical. And that would be our answer. And then just keep in mind, if you notice, for both of these, we used our molar mass, because we were going from mass to moles, mass to moles, moles to mass. Our next type is going to be moles to particles. So up here, these are easier in one way, they're trickier in another way. So if we're looking down here, now we're doing this thing. We have our moles, but now we're going to particles. Oops, I lost something here. And if you look here, we're not using molar mass anymore, we're using Avogadro's number. So it's easier because we don't have to look up a molar mass, but it's harder because you have to figure out what are you talking about. Are you dealing with atoms, ions, formula units, or molecules? So some people like these more, some people like them less. If you look here, they're telling us they want atoms, and they're telling us that we're starting with 3 moles of gold. So we're definitely doing moles and particles one, because that's what they're telling us we have. And I'm going to start off with what they tell me. I have 3 moles of gold. Now remember, you don't have to look anything up. You automatically know Avogadro's number. You know that 1 mole of gold sorry about that. So you just want to make sure for this one, hold on, I need to actually be active. Again, you know the Avogadro's number. You know that 1 mole of anything is Avogadro. So we can automatically write here that we're 6.02. should be O2. I didn't want to write O. Times 10 to the 23rd. Now, the only thing you have to be careful with is you have to make sure that this is actually an atom. Like, you have to think, is gold an atom? So I'm going to just write it up here. This is what gold looks like. So you have to think, okay, is that what an atom looks like? And in this case, it is. That's what an atom is. It's an element by itself that's not charged. So we're okay. And then we just hit equals. And what we should get is 1.81 times 10 to the 24th atoms of gold. And again, the 4 parts of your answer are the number, the sig fig, your unit, and your chemical. So you're almost there. We have 3 more little things, and then we're done. Number 2 is another example. It's just the only thing that's tricky here is this part. We have 3 moles of water, and they want us to go to atoms. Now, you only do this part if they tell you to, because this is tricky. But if you think about water is not an atom. So what that means is we have to do a little extra step. In the beginning, it'll look the same. We still have 3 moles. We know that we have 6.02 times 10 to the 23rd in 1 mole. But what you have to think of now is, what are we talking about? What is water? So is water ionic, covalent? Does it have a charge? So if you look at water and you think about it, it's all nonmetals, which means we're dealing with a molecule. And then why we can't stop there is because they didn't ask for molecules. They asked specifically for atoms. So what we have to do is we have to add a little extra step and say that in 1 molecule, how many atoms are there? And just like we did last chapter, this is why I made us do it last chapter, is you count them up. So we have 2 hydrogens, 1 oxygen, and that means that we have specifically 3 atoms. Again, you only do this if they make you. You do not do this otherwise, because that's just wasting your time. And if you do that, we should get 5.42 times 10 to the 24th atoms.